Hello everyone, hope all doing well. So welcome to our live session. I am Vinith, I am your senior chemistry faculty. So here, fourth unit which is called as carbon and its compounds. So topics covered in this live session. So first is introduction of the carbon and its compounds, how the carbon exists, what is the valency of the carbon, C plus 4 or C minus 4 covalence in each, and the bonding of the carbon, which is nothing but the covalent bond. Why carbon prefers to make a covalent bond. Okay. Next, versatile nature of the carbon. What is versatile nature of the carbon? Why the carbon is different from other elements. Okay. Next, saturated, unsaturated compounds, the structure of the carbon compounds, branch, chain, and rings. Homologous series, the homologous series of the carbon. Nomenclature is nothing but the giving names to the carbon compounds. Next, chemical properties of the carbon. So, chemical properties such as combustion, oxidation, addition, and substitution. Okay. So, there are four chemical properties of the carbon compounds: combustion, oxidation, addition, and substitution. Next, some important compounds of organic chemistry, which is carbon and its compounds. So first is ethanol, which is alcohol, and ethanoic acid, which is also called as vinegar. And soaps and detergents, how the soaps and detergents manufactured with the help of compounds like ethanol and ethanoic acid. And every topic was explained with the help of activities. And last, we are going to discuss the in-text questions, some of the important in-text questions which are continuously repeated in the exam. Okay, so last but not least is the summary. So after completing the complete topic, again in 5 minutes I'll complete the summary. Okay, so here first introduction. So carbon, what is the introduction of the carbon? So carbon atomic number. What is the atomic number of the carbon? Is 6. Carbon atomic number is 6. So here electronic configuration 2, 4. So carbon outermost shell electrons are 4. The valency of the carbon is 4. So carbon, so in previous videos we already discussed that if the outermost shell electrons are less than 4, the atom will try to donate the electrons. If the outermost shell electrons are more than 4, the atom will tries to gain electrons. How many electrons should be gained? So outermost shell electrons should be 8 to be in stable state. So here there are 4. It can gain 4 electrons, it can give 4 electrons. When it gain 4 electrons, carbon will be minus 4 because of excess of electrons, 4 extra electrons. If the carbon gives the 4 electrons away, it becomes C plus 4. C plus 4. So here what happens? Here there are 6 atomic number. That means 6 electrons and 6 protons. So when carbon takes 4 electrons, it becomes 10 electrons and 6 protons. So the nucleus contains 6 protons in the carbon with extra 4 electrons. Okay. So here 6 protons is difficult. It is difficult to hold 10 electrons with the 6 electrons. So that is why it is not possible. So C minus 4 is not possible. And C plus 4. So when carbon gives away the 2, like before in the case, before carbon, it has 6 electrons and 6 protons. After losing 4 electrons, it becomes 2 electrons and 6 protons. Here, there are only 2 electrons in the outermost shell and the size of the shell becomes decreased. If 4 electrons are eliminated from the shell, Kl, if in L shell, if it is completely vacant, the size of the atom decreases. Size of the atom decreases. It is also not possible. So to overcome this problem, carbon makes a special type of bond by sharing its electrons. That is nothing but the covalent bond. Okay. So what is covalent bond? Sharing of an electron with the atom is nothing but the covalent bond. So here sharing of an electron satisfy the octet rules, stable electronic configuration and octet rule. So we go into the topics. First is carbon bonding, which is covalent bond. So what is covalent bond? Covalent bond is a type of chemical bond formed between one, two or more atoms by sharing of an electron to achieve stability. Okay, to achieve stability, the sharing of an electrons between the atoms is nothing but the covalent bond. So how many types of covalent bonds are there? There are single covalent bond, double covalent bond and triple covalent bond. Here there are some examples for the hydrogen atomic number is 1, and hydrogen will share its electron within the hydrogen with itself to become a stable electronic configuration. Here, so two electrons are shared between the hydrogens which satisfy the completely filling of an electrons in the hydrogen. Whereas in the oxygen, there are 6 electrons in the outermost shell. So oxygen need 2 more electrons. So in between the oxygen can make 2 bonds. By making 2 bonds, here 6 electrons in the outermost shell of the oxygen, 6 electrons. 6 plus 6, here it makes 2 bonds, which means it satisfies the octet rule around itself. So oxygen with 6 electrons around it and another oxygen with 6 electrons around it makes 2 bonds. 2 bonds. So if it is making 2 bonds, 2 electrons are participating in the bond formation, remaining 4 electrons are away. So when the 2 electrons are making bond, so here one oxygen will having 4 electrons with the 4 electrons in the bond, like 2 electrons of oxygen, another 2 electrons of oxygen. So total it becomes octet for the each of the atoms. So it satisfies the stability electronic configuration. So single covalent bond, double covalent bond and triple covalent bond. Okay, these are the example for the hydrogen, oxygen and nitrogen bonding. Hydrogen bonding is single covalent bond, oxygen bonding is double covalent bond, and nitrogen triple covalent bond to achieve the stability. This is what the covalent bond. So how can be covalent bond in the carbon? So in the next slides we will discuss about the covalent bond in the carbon. Okay, so carbon having a special character. That character is nothing but the versatile nature of the carbon. There are some points under the versatile nature. So first is tetravalence. So carbon can exist in C minus 4 and C plus 4. C minus 4 means carbon takes 4 electrons, it becomes C minus 4. Carbon, when it donates the electrons, it becomes C plus 4. So tetravalency of carbon. So carbon, not only carbon, silicon also can show the tetravalency. But here carbon can donate electrons, carbon can gain electrons, but it won't gain or uh, lose electrons, but it can make a special type of bond. That type bond is nothing but the covalent bond. And catenation. Catenation is a special character of the carbon, so by which carbon can bond by itself. It forms a long chain. So carbon exists in the different forms in our daily life, like carbon exists as diamond, carbon exists as coal, carbon can exist as petroleum. So different forms of carbon is nothing but the allotropes of carbon. This is just because of the chain formation of the carbon. That property is nothing but the catenation of the carbon. Next is isomerization. What is isomerization? Same molecular formula of the carbon compound, but different in the chain formation. Different in the chain, different in the structure is called isomerization. Let us assume there are 4 carbons in a linear chain. In other, there will be a branch, or else it can be cyclic. So this type of structures are called as isomers. So same molecular formula but different in the structures is called isomerization. The process is called isomerization. These are called as isomers. Okay, hope you understand about the tetravalency of the carbon. Next is ability to form the multiple bonds. So carbon can make single bond, carbon can make double bond, carbon can make triple bond. So here in the case of carbon can exist, single bond, double bond and triple bond. Whereas silicon also can exist in the form of tetravalency, but silicon cannot form catenation and also multiple bonds. So this is the special character of the carbon, that is catenation, tetravalency, isomerization, and last is multiple bond. And here there is another special character is compact size. So carbon size is very small so that it can accommodate four bonds around it, four atoms around itself. So due to the compact size is also the another factor which influencing the versatile nature of the carbon. So carbon is very small, it can accommodate more number of atoms around itself. So hope you understand about the versatile nature of the carbon. Next, we are moving into saturated and unsaturated carbons. So what are saturated and unsaturated? So carbon compounds are three types, actually three types: saturated, unsaturated, and aromatic. Aromatic carbon compounds are not included in your textbook. So here saturated and unsaturated. So under the saturated we have a single bonded carbon single bond is called saturated. So as we are discussed in the previous slide that carbon can exist in three. Carbon can make the multiple bonds, which is a single bond, double bond, and triple bond. If there is a single bond between the carbon and carbon is called saturated hydrocarbons, and they are called as alkanes. They are called as alkanes. And the general formula for the alkanes and saturated hydrocarbons is CnH2n plus 2. What is CnH2n plus 2? If for n number of carbons, we need 2n plus 2 number of hydrogens. Let us assume if one carbon is there, one carbon, how many electrons, how many hydrogens are required? So n is equals to 1 here. So formula 2n plus 2. Now, 2 into 1 plus 2. 2 ones are 2 plus 2, which is 4. So we need 4 hydrogens. For one carbon, we need 4 hydrogens. So let me know in the comment section if there are 6 carbons, how many hydrogens are required. Fast. Yes, 2, 6, 12 plus 2, 14. Yes, very good. 14 hydrogens are required. So carbon can make single bond between itself and also 14 hydrogens. Okay. So alkanes general formula is CnH2n plus 2. Okay. Which gives the number of carbons and number of hydrogens required for the n number of carbons. Okay. So hope you understand about the saturated hydrocarbons. Saturated hydrocarbons are nothing but single bonded carbons. So carbon single bonded. So there is another case, like sometimes carbon can bond a double bond with oxygen, any other atom, and single bonded with carbons. Single bonded. Is it a double bonded carbon? No, it is not a double bonded carbon. This is a single bonded carbon. In between the carbons, we have only single bond, whereas in between oxygen and carbon, we have double bond. We don't consider the double bonds or triple bonds between the carbon and other atom. We consider only double bonds or triple bond between the carbon itself. So here saturated hydrocarbons are nothing but carbon-carbon single bonds, and the general formula for them is CnH2n plus 2. Okay. Next is unsaturated hydrocarbons. What are unsaturated hydrocarbons? Okay. Unsaturated hydrocarbons are one triple bond or one double bond. Okay. The carbon-carbon having a double bond or triple bond is called as unsaturated hydrocarbons. See, carbon-carbon double bonded, carbon-carbon triple bonded are called as unsaturated hydrocarbons. Unsaturated hydrocarbons are classified into two types: alkenes and alkynes. So what are alkenes? What are alkenes? So here alkenes means the double bonded carbon, and the general formula Cn with H2n. So for n number of carbons, we need 2n number of hydrogens. Okay. So let me give one example. If there are two carbons, we need 2 to the 4. 2n means 2 into 2. 2 to the 4 hydrogens for the 2 carbons. Okay. So let me know in the comment section if there are 7 carbons, how many hydrogens are required? 14. Yes, very good. 14. If for 7 carbons, we need 14 hydrogens. So n number of carbons, we need 2n number of hydrogens. Okay. For the alkanes will be like this, but whereas for the alkynes, So what will be the alkynes? Alkynes are nothing but triple bonded carbons. Carbon-carbon triple bond is called as alkynes, and it should contain at least one triple bond between the carbon-carbon, not with the carbon and other atom. And the general formula is 2CnH2n plus 2. CnH2n minus 2. Sorry, CnH2n minus 2. So for n number of carbons, we need 2n minus 2 number of hydrogens. So let us assume 3 carbons are there and the number of hydrogens required. 2, 3 is 6. 2, 3 is 6 minus 2. 6 minus 2 will be 4. 6 minus 2 will be 4. So let me know in the comment section if there are 5 carbons, the hydrogens required. 5 to 0, 10, 10 minus 2, 8. Very good. C5H8. So this is the general representation of the saturated and unsaturated hydrocarbons. Saturated are single bond between the carbon, and the general formula is CnH2n plus 2, and whereas unsaturated hydrocarbons are nothing but carbon-carbon double bonds or carbon-carbon triple bonds. And the general formula for this are, there are classified into two types. Carbon-carbon single double bond is called as alkenes, and the general formula for them is CnH2n. Okay, and alkynes are nothing but triple bonded carbons. Carbon-carbon having triple bond is called as alkynes, and the general formula for them is CnH2n minus 2. Okay, so hope you understand about the saturated and unsaturated hydrocarbons. Okay, next we are moving to the examples. Example for the saturated and unsaturated. Saturated hydrocarbons are carbon-carbon single bond. Unsaturated comes under alkenes and alkynes, double bonded and triple bonded. Okay, chains and branches and rings. Chains, so carbon can exist in the form of chains, linear chains, and it can exist in the form of branch and rings. So what are chains? The sequence, linear combination of the carbons is called chain structure. So chains are arrangement where the carbon atoms are linked in a straight line or a simple sequence is called as chains. And whereas branch, when two or more carbon atoms, when two or more carbon atoms are attached as a side groups to the main carbon chain. Let us assume here C, 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 C. This is a linear chain. C, 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 C. This is also a linear chain because it is a sequence line. Whereas here, let us assume this is a linear chain sequence. So if the carbon is attached in between the linear chain, that will be considered as branched one. So this is branch. And what is about the ring? Okay, rings are nothing but the carbon compounds or carbon structures are attached in a cyclic way or in a loop is called as carbon with the ring forms. So here this same number of carbons 1, 2, 3, 4, 5 are attached in a loop are called as ring forms. Okay, these are called as rings. So there are three different structures of the carbon compounds: chain, branch, or rings. Okay, these are about the structure of the carbon compounds. Next is, so the general representation of the chain will be like this. So these all are alkane compounds, single bonded compounds. So single bonded compounds. So carbons are attached in a linear way, and each carbon can make 4 bonds around itself. 4 bonds itself. So here there are single bonded between the carbons, single bonded between the carbons. Here there are single bonded between the carbons, and each carbon can make 4 bonds around itself. So here 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each carbon can make 4 bonds around itself. So this comes under the branch chain. So linear carbon chain is attached with another carbon, so which is comes under the branched chain of the carbon, and this is linear. But here the carbons are attached in a loop way, that is why they are considered as a cyclic ring. Okay, so this is a chain, branch and the cyclic ring. Okay, this is what about the structure of hydrocarbons. So next is functional groups. So what are functional groups? See here in the this carbon and compounds is also called as hydrocarbons, because carbon is making bond with the hydrogen, because carbon is in very small and hydrogen compared to the carbon size is little small, and compared mostly it will be equal. So when carbon can make easily bond with the hydrogen, so that is why the carbon compounds are called as hydrocarbons. But sometimes hydrogens from the hydrocarbons are replaced by the other atoms. Other atoms, like let us assume if they are replaced by OH. OH is a functional group. OH is the alcoholic functional group. It is called as hydroxyl functional group, OH, and the compounds are alcohol compounds, and the example for them is methanol and the suffix. So what is suffix in the nomenclature? While naming the carbon compound, there is a separate topic about the nomenclature of the carbon. So that in that nomenclature, the suffix means the last ending part of the name, it ends with the OL. Okay, and aldehyde CHO. CHO means C double bonded OH, and here it comes aldehyde CH3COAl. Okay, CH3COAl, and carboxylic acid COOH, ketone C double bonded O, and ester COO, ether COC. Haloalkanes are chlorine, bromine, iodine, and the alkenes double bonds, alkynes triple bonds. Okay, these are the examples for them, and the suffix names. This functional groups again we will discuss in the nomenclature very detailedly while naming the compounds. Okay, so this is just for the review, I mean just for the brief introduction about the functional groups. Next is the homologous series. So what is homologous series? Okay, homologous series is nothing but the a series in the carbon compound which is having the difference with CH2. So let us assume CH4. CH4 is called as methane, but in the nomenclature we will discuss again in the detailed form. Okay, so methane. So after this, this is a single bonded alkane compound. So for this, if you increase it with C2H, if there are two carbons in the alkane, how many hydrogens are required? Let me know in the comment section. C2, for C2, 2n plus 2 formula. 2 2 is 4 plus 2 6. Very good. 6 carbon, and after this C3H, 3 2 is 6, 6 plus 2 8. So if you observe here, one carbon having, so the difference between the two sequence series is having one carbon and two hydrogen difference. Here also one carbon, two hydrogens difference. Okay, after this also C4H10. So here's it. So the series with the CH2 difference is called as homologous series. It can be same functional group. It should have same functional group. Here the all are single bonded compounds, alkanes. So first homologous series of the alkanes is methane, ethane, propane, butane. Again in the nomenclature we will discuss in a detailly. So when it comes to the name of the compound in the nomenclature we will discuss about this. Okay, so homologous series. And if you have a doubt about, see, like carbon is bonded with 4 hydrogen and 1 alcohol. After this, what will be the homologous series of this? Methanol. This is called as methanol. So after this, two carbons with single bonded, each carbon can make 3 bonds like hydrogens around it. So let us assume here 2 hydrogens are there, remaining is alcohol. So the homologous series of the alcohols is first is this, second is this, and after that as the chain increases, the number of carbons, 1 carbon increases, 2 hydrogen increase. The difference between the series is CH2, then the series is called as homologous series. Okay, so this is what about the homologous series. The successive member differs with the CH2, then it is called as homologous series. The series of carbon compounds with different CH2 is called as homologous series. Please note it down, students. Next is homologous series. First example, Methane, for methane, after methane, propane, ethane, propane, butane, pentane. So this is the alkenes. In alkenes, it starts with two carbons. Why it starts with two carbons? Here it starts with single carbon. Here it starts with two carbons, because double bonded is possible between the two carbons, not with the single carbon. So double bonded ethene, propane, butane, and pentane. So if it is the first homologous series of the alkene, so the third homologous series of the alkene will be butene, not the propene. But in the case of alkanes, 1, 2, 3, propane will be the third homologous series, whereas in the alkenes, third homologous series will be the butene, not the propene. Keep it in the mind, okay? Next, alcohols. Alcohols means same. Methanol, ethanol, propanol, butanol, pentanol. So here if you observe the number of carbons, here 1 carbon, 2 carbon, hydrogens 1, 2, 3, 1, 2, 3, 4, 5. So from here to here 2 hydrogens increased, same OH groups is attached. So there is no change in the functional group. As the sequence increases, number of carbons increases, 1 carbon and 2 hydrogen increases. That series considered as homologous series. So this is what about the homologous series of the carbon compound. Next is nomenclature. Okay, nomenclature is very important. Let me tell you what is the structure of the nomenclature. So it starts with prefix. After prefix we have root word and primary suffix and secondary suffix. Primary suffix, secondary suffix. So let me tell you what is prefix, root word, primary suffix and secondary suffix. So first, root word is nothing but the number of carbons. So if there are 1 carbon, then the root word will be meth, 2 carbons eth, 3 carbons prop, 4 carbons but, pent, hex, hept, oct, non, dec. Okay. So the number of carbons is named as a root word in the nomenclature. So root word is nothing but the number of carbons. So number of carbons can be 1 carbon, 2 carbon, 3 carbons. As the number of carbon changes, the name nomenclature also changes. So if there are 1 carbon, meth, 2 carbons, eth, prop, but, pent, hex, 6 carbons, hex, 7 carbons, hept or sept, 8 carbons, oct, 9 carbons, non, 10 carbons, dec. Okay, number of carbons is the root word, which comes as a second position of the nomenclature. And primary suffix. What is primary suffix? Primary suffix is the type of bond. If the carbon is having single bonded, then the name ends with ane. If the carbon is having double bonded, ene, triple bonded, ine. Okay, that is what the primary suffix. Primary suffix is nothing but type of bond. It can be single bond, double bond and triple bond. Okay, hope you understand about the root word and the primary suffix. Next is the secondary suffix. What is secondary suffix? Secondary suffix, as we discussed in the previous slide, that there is a table with the groups are called as functional groups. What are functional groups? Functional groups are the groups which can replace the hydrogen and the which shows the different characteristics or properties of the carbon chain. So here there are different functional groups like alcohols, aldehydes, ketones, carboxylic acid. For each of the functional group there is different suffix. For alcohols we have ol, aldehyde CHO, al, ketone ends with on, carboxylic acid ends with oic acid. Okay, this is what about the root word, primary suffix and secondary suffix. What is prefix then? What is prefix? So here prefix means these groups are also considered as functional groups, but except this, like these are called as halogen groups, halo functional group, halogen. Halogen means in the periodic table, the 17th group is considered as a halogens. So chlorine, bromine, iodine are considered as a halogen except this nitrogen, nitro compound. So halogens and the nitro compounds are considered as the prefix. And also alkyl chain. What are alkyl chain? Alkyl chains, alkyl groups or alkyl branched chains are nothing but the, so let us assume alkane. Alkane, which is CH4. Alkane. So if you remove one hydrogen from this becomes CH3, which is considered as alkyl group. So alkyl groups are nothing but if you remove one of the hydrogen from the alkane compound, then it becomes alkyl. Alkyl can be methyl, ethyl, butyl. Methyl is CH3, ethyl is C2H5, propyl is C3H7. Like this, there will be a functional groups. They are considered as alkyl groups, which comes as a prefix in the nomenclature. Okay. So here, before naming the compound, let me tell you in a briefly. So what are the steps included in the nomenclature? How we can write the nomenclature? Okay. So here, if they give you the molecular formula, what is the procedure you follow to write the nomenclature? Okay. Sir, what is that screen? Sorry for the disturbance, children. Sorry. Okay, here. So select the longest chain first. Select the longest chain means if it is like C carbon and it is branched. Okay. So while counting the number of carbons, let us assume 1, 2, 3. So this is the shortest chain. So don't consider the shortest chain. 1, 2, 3, 4, 5. This is also a shortest chain. Okay. If you are considering like 1, 2, 3, 4, 5, 5 it comes 5. 1, 2, 3, 4, 5. It is also 5. So you can choose any type of chain which is more in number. Okay. So here you can choose like this, or else you can choose like this. So any type you can choose. Any type you can choose. So it can be like linear chain or branched chain or anything. Okay. So here you have to choose the longest chain before doing any giving a name of the compound. Okay. Before giving a name of the compound, you should choose a longest chain and identify the type of position of bonds. Okay. Type of bonds, it can be single bond, double bond or triple bond. And also after finding the if it is a single or double bond or triple bond, just go into the functional group, identify the functional group and the position. Okay. Last nothing but least is a prefix. So in your textbook there is no such prefix. So what are the prefix? It can be like prefix, like it can be numbers or it can be single. If it is single, if the functional group like same chlorine is being used in the first position and the second position, then we can tell it, then we can name it as like single, mono or di. Like if it is a single, we don't need to use any prefix. If it is a two compounds, we use di. If it is three, tri. So like this we will use in the prefix and substitutions. Okay. Next, how many structural isomers can you draw for the pentane? So what are structural isomers? Like first, pentane. Okay. Pentane. What is pent? Just write the name of the given compound, pentane. Just identify the root word, pent. Pent means 1, 2, 3, 4, 5. 5 carbons. And ane means type of bond is single bond between the carbons. So how many hydrogens are required for the each carbon? So here carbon is making single bond. It needs 3 hydrogens. It needs 3 hydrogens, whereas here it needs 2 hydrogens. 2 hydrogens because it is already having 2 bonds. So each carbon can make 4 bonds around itself. There are 4 bonds. So that is why here single bonded carbon can make 3 bonds with the hydrogens. Okay. This is what the structure of pentane. Okay. Structural isomers of the pentane. Structural isomers means what are isomers? Same molecular formula but different in structure. So how can we write this formula? So just write the chain 1, 2, 3. And for this we can keep one carbon, single bonded, single bond. So it is the different structure. We having 1, 2, 3, 4, 5 carbons. So just we need to keep the number of hydrogens. 1 hydrogen, 2 hydrogens, 3 hydrogen. Why we are keeping 3 hydrogens? Because carbon is having already 1 single bond. So remaining 3 bonds will be hydrogens. Here hydrogen, hydrogen, hydrogen. Here hydrogen, hydrogen and hydrogen. Okay. Hydrogen, hydrogen and hydrogen. So this is what the another structure isomers of the pentane. So you can write like this also, like 1, 2, 3, 4. 4 carbons, and you can place a carbon here also or here also. So any place is possible, but here it should be 5 carbons. So if you are placing here carbon, you know you don't need to keep here. So it can be one isomers, it can be another isomers here. So same molecular formula, if you count the number of carbons here, 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Same number of carbons. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here the same molecular formula but different in the structure is nothing but the structural isomers. Okay, hope you understand about the structural isomers and the nomenclature, little bit about the nomenclature. Next is, what are the two properties of the carbons which leads to the huge number of carbon compounds we can see around. So carbon having a special character, that is the versatile nature of the carbon. Here it is, one is versatile nature, versatile versatile nature. Under the versatile nature, we have different properties like tetravalency, catenation, isomerization, and also compact site multiple bonds. So here, what are the two properties which lead to the huge number of carbon compounds? First is catenation, and it can be isomerization. What is isomerization? Same molecular formula but different in structures. Catenation means linear combination. I mean chain formation of the carbons is nothing but the catenation. So catenation is nothing but carbon can make multiple bonds, not only multiple bonds, n number of chain is nothing but the catenation. Okay, two properties of the carbon which leads to the huge number of carbon compounds. Next is, what will be the formula and the electron charge structure of the cyclopentane. Cyclopentane electron charge structure and the structure. So let me write the formula first. Cyclopentane. What is cyclopentane? Cyclo means cyclic structure. Pent means 5 number of carbons in a cyclic manner. 1, 2, 3, 4, 5. Combine with the single bond because it is a ane compound. Ane. Okay, cyclopentane is like this, and the number of bonds required for the carbon. So each carbon is making 2 bonds already. So remaining 2 bonds can be hydrogens. Hydrogen here, hydrogen, 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 hydrogen here, hydrogen. Okay, so this is what the structure of the cyclopentane. And what will be the electron dot structure? Electron dot structure can be same like this, but it should be dot, like 1, 2, 3, 4, 5. So outermost electrons can be kept as a dots around the atoms. So how many electrons are there around the carbon? 4. Okay, so 4 dots. 1, 2, 3, 4. Why like this? Because to make the bond. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is one bond between the carbon. One bond between the carbon. Carbon bond. So this is the carbon bond. Remaining 2 bonds can be hydrogens. So hydrogen with each dot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here is the dot structure of the cyclopentane, and this is what the structure of the cyclopentane. So you can draw like this. With the help of structure, you can draw the structure of electron dot structure of the any structure. Okay, so next, draw the structures using the following compounds. Ethanoic acid. Okay, so whenever he asks you to write the structure, just write the name, given name of the compound, divided into prefix, root word, primary suffix and secondary suffix. So if you see here, it is a root word, it is number of carbons. How many carbons are there? 1, 2. It means 2 carbons. And after that we have ane and oic acid. Ethanoic acid. Ethanoic acid means ane. Ane is single bonded between the carbon. Oic acid. So what is oic acid? COOH, which is carboxylic acid. C double bonded OH is the carboxylic acid. To any of the carbon you can keep oic acid. So C double bonded OH here. And here oic acid is completed. So here it is carbon is having 1, 2, 3, 4 bonds already. So remaining bonds will be here. Remaining 3 bonds for this carbon will be like this. CH3COOH is called ethanoic acid. So this is how we will write the structure of the given compound. Next is bromopentane. So in the bromopentane we have prefix. Bromo is prefix, pent is root word, ane is primary suffix. So first you write the number of carbons. Pent means 1, 2, 3, 4, 5. Single, and we have ane. Ane means single bonded between the carbon. Okay, single bond between the carbon. Bromo, you can keep bromine group in the first position, second position, third, fourth, fifth, any position. So let me keep it in the first position, bromo. So here this carbon is making 2 bonds, remaining 2 bonds can be hydrogen. Here remaining 2 bonds can be hydrogens. Hydrogens here, hydrogens and hydrogen. Okay. So this is what the structure of bromopentane. Bromo can be first position, second position, third, fourth, fifth, any positions you can keep the bromo. So they didn't mention the position, you can write it anyway. Okay. Next is butanone. Butanone, buta is the number of carbons. But 4 carbons, 1, 2, 3, 4. Ane means single bond between the carbon. None. What is none? None is a ketone functional group. Ketone functional group will be like this: C double bonded O, 1 bond, 1 bond. So always remember, ketone should be in the middle of the carbon chain, but not in the first and last. First and last you cannot keep the CO, because it should have CO. First front side it should have 1 bond, back side also it should have 1 bond. So that is why it never, ketone be never in the first position and the last position, it can be in the middle carbon. Here also carboxylic acid can be last and first carbon, but it cannot be in the middle carbon, because COOH itself is a functional group. So you should keep 2 oxygen with hydrogen will be the ethanoic acid, carboxylic acid, here ketone. So any of the carbon you can keep double bonded O, this is a ketone functional group, remaining all will be hydrogens. 1, 2, 3, 1, 2. Already 2 bonds are there, 3. So here 1 bond, 1, 2, 3. So this is what butanone. So butanone, yes, any doubts? Okay. So can we keep the ketone in the third position? Yes, you can keep in third position, but not in the fourth position, in the first position, because ketone is a middle functional group. It can be in the middle, but not in the first and last position. They are called as in between functional groups, middle chain functional group, and these are terminal functional. It can be first position and the last position. Okay. So this is what the butanone. Next is the hexanol. Okay. What is hexanol? Hexanol. Hex means 6 carbons. 1, 2, 3, 4, 5, 6. Single bonded between the carbons. And ane is single bond. And nol, al means CHO. CHO actual form will be C double bonded OH. This is the terminal functional group. Terminal functional group means it can be in the first position or last position. So if you keep here double bonded OH, and the remaining all are hydrogens. 1, 2, 3, 1, 2 here, 2 hydrogens here, 2 hydrogens, and here 2 hydrogens. Hexanol. This is what the hexanol structure. Okay. Hexanol structure. So with the given form, with the given formula, you can draw the structures like this. With the given structures, you can write the formulas like this. Okay. So are structural isomers possible to the bromopentane? Yes, bromopentane structural isomers possible, because bromo can be first position, second position, third, fourth, fifth position. Any positions it can be. So positional isomer structure means, can we change the structure of the pentane? So we can change the structure of the pentane. This is a linear chain, branched chain also possible, branch chain also possible, cyclic also possible. Okay, bromopentane anytime. Okay, this is what the structural compounds. Writing the structures of the given compound, you can able to write the uh, names of the compounds with the given structures. Okay. Next, here. Here is the example for the IUPAC nomenclature, names of the compounds. So first is CH3CH2Br. CH3CH2Br. Just find the prefix, root word, primary suffix and secondary suffix. First, prefix is bromo. Why it is bromo? Bromo comes under a prefix, bromo. And the number of carbons, 2 carbons. 2 carbons means eth plus what is the type of bond? Single bonds are there. Single bond between the carbon-carbon chain. That is why it will be AN. Plus, is there any functional group? Is there any functional group in the given structure? Let me know in the comment section. No, there is no functional group. Sir, hydrogen functional. No, ma. Here, hydrogens cannot be a functional groups. Always remember, hydrogen cannot be a functional group. Any other than hydrogen will be a functional group. Okay. So, bromine is a functional group, but which comes as a prefix, ethane. So, bromoethane. Finally, it is bromoethane. Okay. Next is H double bonded O. Okay. Sorry. Here we have H here, CO. So if there are one carbon, then it will be, the root word is meth. Is there any functional group? Is there any functional group means, here if you consider this hydrogen as a chain, CO with H is called, C double bonded OH is called which type of functional group? Let me know in the comment section. Yes, aldehyde with Al. So we have single bonds, and carbon with the other carbon is not having any type of bond. It can be single bond. So here we have single bond means An, with the secondary suffix is aldehyde, which is Al. So if the secondary suffix is starting with the letter vowel letter. Vowels are A, E, I, O, U. If it is starting with this, so you just need to cancel this. So meth plus anal, methanol. This is methanol. Okay. Next, this one. Okay. Here, they have given the structure of the given compound is the carbon chain 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. In between the fifth and sixth carbon, we have triple bond. Hydrogen over here. There is no hydrogen, single bond. Here, hydrogens, single bond, single bond, single bond. 3 hydrogens here. 2 hydrogens, 2 hydrogens. Count the number of carbons first. Okay. 1, 2, 3, 4, 5, 6. 6 carbons are there. 6 carbons, the hex. It comes hex. Okay. Is there any functional group? So if you see here, there is single bond between the carbons and the triple bond. So when there is a single bond and triple bond, you should consider the more number of bonds, that is triple bond. If there is a double bond and triple bond, both you will consider the both double bond and triple bond. But if there is a single bond and double bond, you should consider double bond. Single bond and triple bond, you should consider the triple. So here there is a triple bond. So with the triple bond means the unsaturated compound, which is alkyne. Alkyne suffix is -ine. So hexyne. The name of the compound is hexyne. That is what the nomenclature of the given structures. So this is how you can write the names for the given structures. Okay. Hope you understand about the nomenclature and the structure with the names. Okay. Next, chemical properties of carbons. Chemical properties of carbons. We have four types of chemical properties, chemical reactions. First is combustion. Next is oxidation, addition reaction, and substitution reaction. Let me tell you, first is combustion reaction. Combustion is carbon compounds, and combustion will give you three major compounds, which is carbon dioxide, heat, and light with water molecules. Okay, like when carbon itself is a coal which is combusted in the presence of oxygen. Combustion means we require oxygen. It gives carbon dioxide gas, heat plus light. So carbon in all its allotropes. Allotropes means different forms of the carbon forms. It on combustion in the presence of oxygen gives heat, carbon dioxide, light. So heat is the extra thing which is the exothermic nature of the combustion of carbon compounds. So most carbon compounds releases large amount of heat and light. Okay, heat and light on combustion. So this is what about the combustion. Because combustion requires oxygen. On combustion, carbon compounds will give you the carbon dioxide, which is a effluent, heat and light from the as a product. Okay, so in detail, what is combustion? So here, when you combust the carbon compounds, you can observe the different types of colors of flames and the smoke. So saturated hydrocarbons when on combustion will give you the clean flame, which is a blue color flame or clean flame, and there is no any smoke. And but unsaturated compounds when on combustion will give you the yellow color flame with the black smoke. That is nothing but the sooty flame, which is very dangerous. Carbon, it is called as black carbon, BC, black carbon. So here the gas or kerosene stoves used at home having the inlets of holes under the gas. So why there is a inlets big holes under the gas stove? Because to provide the sufficient oxygen for the combustion. So if there is no sufficient oxygen for the combustion also, it will give you the yellow color flame and the sooty flame. Okay, sooty is nothing but the smoky flame. So there are two types of flames, clean flame and yellow color flame is responsible because of the saturated and the unsaturated nature of the carbon compounds. Okay, so smoke is because of less not sufficient oxygen and also unsaturated hydrocarbons. Okay, hope you understand about the combustion. Next is oxidation. So what is oxidation reaction? So oxidation reaction is the conversion of the carbon compounds by oxidizing it. So one example is alcohols are converted into carboxylic acid. Let me take one example which is alcohol CH3 CH2OH. This is considered as ethanol. It is two carbons with alcohol is called ethanol. Ethanol in the presence of KMnO4, alkaline KMnO4 or K2 acidified K2Cr2O7, which is called as oxidizing agent. This is potassium permanganate and then this is potassium dichromate. Potassium permanganate, potassium dichromate. These are called as oxidizing agent. Oxidizing agent means the one which adds the oxygen or else the one which removes the hydrogen. So this converts into CH3 COOH, which is nothing but the ethanoic acid and also acetic acid. Okay, CH3COOH. So here what happens? Number of carbons, two carbons same, three hydrogen here, 3 plus 2, 5 hydrogens here, only 3 hydrogens are, 2 hydrogens were removed and OH is converted as OOH, double OH, oxygen is being added by this compounds. These are called as oxidizing agent and this reaction is called considered as oxidation. So oxidation means addition of oxygen with some oxidizing agent which converts the reactant from deoxidized to oxidized. I mean addition of oxygen is done in the oxidation reaction. So alcohols are converted to carboxylic acid with this reaction. Okay. So here next is addition reaction. So what is addition reaction? To which type of addition which type of compounds are undergoing addition reaction. So addition reaction is only possible in the unsaturated hydrocarbons. So what are unsaturated hydrocarbons? addition reaction, unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium and or nickel to give the saturated hydrocarbons. So why not saturated hydrocarbons are not participating in the reaction? Saturated hydrocarbons does not participate in the reaction because they are having the sufficient number of single bonds around it. But whereas for the unsaturated are double bonded or triple bond. Okay. So let me take one example. Carbon-carbon double bond. Carbon-carbon double bond with two hydrogens. Two hydrogens on addition of hydrogen in the presence of palladium. Palladium is a catalyst. So catalysts are nothing but the which enhance the rate of the reaction, which enhance the speed of the reaction but does not participate in the reaction. These two hydrogens are added to one hydrogen to this and another hydrogen to this. Then as a result, one of the bond is removed from the middle, that becomes C with three hydrogens, carbon with three hydrogen with single bond hydrogen. This is nothing but the unsaturated hydrocarbon is converted into saturated. Double bonded is converted into single bond. So mostly remember animal fats are saturated fatty acids which are said to be harmful. Always remember saturated fatty acids are harmful for our body and they are converted to unsaturated fatty acids. I mean, whereas oils containing the unsaturated fatty acids are chosen for the cooking. Okay, so when unsaturated hydrocarbons like vegetable oils are kept in the air, like hydrogenation, on hydrogenation they are converted to saturated hydrocarbons which are very harmful. We should not consume the saturated, but we can consume unsaturated. Okay, what is the application of the addition reaction? Where we can see the addition reaction? Addition reaction mostly this can be used for the industrial purpose to convert the vegetable oil to the vegetable ghee. Vegetable oil is the unsaturated fat. Unsaturated fatty acids, double bonded fatty acids on hydrogenation they can be converted as the vegetable ghee which is the saturated. Okay, so this is what the industrial application of the addition reaction. Next is the substitution reaction. Substitution reaction means, so here C with carbon with 4 hydrogen. Carbon with 4 hydrogen. However, so substitution reaction means saturated hydrocarbons are fairly unreactive because they are having single bond around it, but are inert in the presence of mostly reagent. Inert means they cannot react with any of the compounds because of this. These saturated hydrocarbons are having single bond around it. But however, in the presence of sunlight, chlorine is added to the hydrocarbons in a fast reaction. So when chlorine reacts, methane reacts in the presence of chlorine, in the presence of sunlight, H nu is sunlight, it gives C with carbon with 3 hydrogens. One of the hydrogen is being replaced by the chlorine. It is nothing but the substitution reaction. One of the hydrogen is substituted by the chlorine and also the extra product is hydrogen plus chlorine, hydrochloric acid. Okay. So this is how the substitution reaction will be. So saturated hydrocarbons in the presence of sunlight, chlorine replaces the one of the hydrogen from the hydrocarbons giving the substituted compound. So chlorine can replace the hydrogen atom by 1 by 1. Okay, so this is what the substitution reaction. So we have completed the 4 types of reaction, that is combustion reaction, oxidation reaction, addition reaction and substitution reaction of the organic compounds. Next topic is very important. Here we have some important compounds in the carbon compounds. There are 2: ethanol, alcoholic compound, ethanoic acid, carboxylic compound. So first, properties of the ethanol. Okay, so ethanol, we already know that ethanol is an alcoholic group because it contains the alcohol functional group, so which can be used as the active compound of the alcoholic drinks, active ingredient of the alcoholic drinks, and they can be used in the medical purpose also. They are used as an ingredient in the tincture iodine, cough syrups and tonics. Okay, here most of the organic compounds are insoluble in water except one compound, which is ethanol. Ethanol will dissolve in the water in all proportions. So you can dissolve the ethanol in water in all different proportions. So ethanol is soluble in water. Okay, So this is what the properties of the ethanol. Next, chemical properties of ethanol. So ethanol on reaction with the sodium. So ethanol, one example, ethanol is nothing but CH3CH2OH. When it reacts with sodium, it gives what? Evolution of the hydrogen gas, because sodium replaces the hydrogen from this. So it gives, when hydrogen being replaced from the ethanol, it gives CH3CH2ONA. This is nothing but the sodium ethoxide with hydrogen gas. So this is what the reaction between the alcohol and the sodium metal. And reaction with the unsaturated hydrocarbons. Unsaturated hydrocarbons means, so CH3 reaction to give unsaturated hydrogen, CH3CH2OH. When it reacts with the H2SO4 and heating, it gives, so from this hydrogen OH and hydrogen being removed, it gives CH2 double bond CH2, which is nothing but the alkene compound. This is unsaturated hydrocarbon. So alcohols on reacting with the acids in the presence of heat, it gives unsaturated hydrocarbon. This is nothing but H2SO4 is nothing but the dehydrating agent. Dehydrating agent means from this water molecule is being eliminated, water is removed. So dehydration of ethanol gives ethyl. Dehydration of ethanol gives ethyl is the reaction between the alcohols and the H2S4 acid. So next reaction is, the ethanoic acid. With an ethanoic acid which is acidic, which has the acidic nature. So ethanoic acid is also called as acetic acid. So ethanoic acid is also called as acetic acid and belongs to the carboxylic group. Most of the acids contain, like HCl, HNO3 are considered, H2SO4 are acids. They are called as mineral acids. But here in this case, COOH, carboxylic acid, is the another type of acids, like from ethanoic acid. Ethanoic acid is also called as acetic acid. From the ethanoic acid, 8 to 10% of solution in water is considered as vinegar, which we use it for the preserving agents, or else it can be used in the cooking, like Chinese fast food dishes. Okay, so vinegar is used as a preservative for the pickles. Okay, so here vinegar is also called as, vinegar or acetic acid is also called as glacial acetic acid. Why it is called as glacial acetic acid? The important thing about the ethanoic acid is glacial acetic acid, because the melting point of the pure ethanoic acid is 293 degrees. 293 Kelvin means around 17 degrees. Around 17 degrees, it starts freezing. It looked like a snow. That is why it is called as glacial acetic acid. It looked like glacier. So here it was the, that is what about the ethanoic acid properties and the chemical reaction of the ethanoic acid. So first reaction is esterification, making the esters with the help of ethanoic acid. So when ethanoic acid, like first alcohols, CH3CH2OH, alcohols reacting with CH3COH, ethanoic acid. So from this OH and from this hydrogen being removed, eliminated as the water molecule. So this comes and attached here. This becomes CH3 COO CH2 CH3, which is nothing but the ester. COO compound is called as esters. So this esters gives a sweet smell. That is why they are used in perfumes and flavoring agent. So what is esterification? Esters are most commonly formed by the reaction of acid and alcohol. Ethanoic acid reacts with the absolute ethanol. Absolute ethanol is this. So in the presence of acid catalyst to give a ester. This ester are sweet smelling substances used in the making perfumes and flavoring agents. Okay. So esters are the sweet compounds, can be used in the flavoring agents or sweet smelling because of their sweet smelling property. Okay, so these esters again on reaction with the base, again on treating that ethers with the base, CH3 COO CH2 with CH3 is called as ether on reacting with sodium hydroxide, sodium sodium goes and attack to this carboxylic acid. OH will attack to this. This gives CH3 COO minus Na plus CH3 CH2OH, which is CH3 CH2OH is the alcohol. Again we will get alcohol. This is nothing but the sodium salts of carboxylic acid. This is the major is the large amount of, the major ingredient in the soaps. So the reaction is known as saponification. Why it is called as saponification? This is the ingredient used in the soaps. So because it is used in the preparation of soap. Okay. So this is called as sodium salts of carboxylic acid. This is soap used in the soap preparation, saponification. So before reaction is esterification, this is saponification. Esterification product esters on reacting with the base gives the sodium salts of the carboxylic acid. This sodium salts of the carboxylic acid, this sodium and the carboxylic acid COO with CH3, this is considered as a tail and this is considered as a head. So head and tail. So this tail is hydrophobic. Hydrophobic means this does not react with the water molecules. So this hydrophobic end will stick to the dirt. So what is the application of this soap in the dirt or while removing the dirt? So here on reacting with the base, same reactions. On reaction of ethanoic acid with the base, on reaction with the sodium, on reaction with the carbonates or hydrogen carbonate, this reaction we discussed in the unit 1. Acids on reacting with the bases. Acids on reacting with the bases will give you the salt, carbon dioxide and water. Okay. So this is the reaction between the ethanoic acid and the carbonates or hydrogen carbonate. Reaction with base, when acid reacts with the base gives salt and water. This is the another reaction of the ethanoic acid. So what is the application of the ethanoic acid? So ethanoic acid application is soaps and detergents. So ethanoic acid on reaction with the ethanol gives the ester. Ester, this reaction is called esterification. Ester on reacting with the base gives the sodium salts of the carboxylic acid. Sodium salts of the carboxylic acid is nothing but the soaps which is used in the preparation of soaps. That soaps having the head part and the tail. So most dirt is oily in nature and oil does not dissolve in water. Oil does not dissolve in the water. So here the molecules of soaps are sodium or potassium salts of the carboxylic acid. Na with the head and remaining COO and CH3. This is the tail. This is head. Considered as head. So here the ionic end of the soap interacts with the water. This is called as ionic end. This interacts with water and the carbon chain reacts with the oil. So this carbon chain reacts with the oil. So if there is a oil, it is surrounded by the tail parts and the head parts are ionic end. Ionic end interacts with the water. This interacts with the water and this interacts with the dirt. Let us assume this is a dirt. So dirt. So dirt interacts with the dirt is interacted with the tail part. Tail will hold the dirt, which is a oily part. So dirt is oily, tail is also oily. Oily golly get attracted each other and the head part is washed away with the water. When head part washed away with the water, followed by tail followed by the dirt. So this is how the dirt is being removed from the clothes. Okay, hope you understand the mechanism of the soaps on removing the stains, which is oily stains. Okay, this is the called as micellar. Micellar is called as when the oily stain is surrounded by the head and the tail part of the sodium salts of carboxylic acid. This is considered as the micellar. Okay, hope you understand about the micellar. So next is detergent. Okay, so what are detergents? what is the need of detergents? Why, when we are having soaps, why we are not using soaps in the place of detergents? So detergents are little different compared to the soap. So soaps, when they react with the like heavy metals, if the water is having heavy metals like calcium and magnesium, they will interact with the soaps, will interact with calcium and magnesium, which becomes the water, which makes the water hard. So the reaction of soap with the calcium and magnesium, which salts, which gives us hardness of water. This hardness of water can be removed with the help of detergent. So hence we need to use a large amount of soap. So that is why when we use the large amount of soap also, it will be very difficult to remove the calcium and magnesium. So that is why this problem can be overcome using the another class of the compounds called as detergent and the cleansing agent. So what are detergents? So detergents are nothing but the sodium salts of sulfonic acid. Sodium salts of sulfonic acid or ammonium salts are called as detergents. So detergents, when the charged species of the detergents like sulfonic end and the head part, which is the sodium salt. So head part is hydrophilic, tail part is hydrophobic. So the charged end do not, this detergent do not soluble with the heavy metals. Heavy metal, they won't react with the heavy metals, they won't soluble. So they will form a foam, which is the lather. So detergents, when it reacts with the soluble, when they react with the heavy metals, they form the lather, which is a foam. It goes up, in the water. So with the help of removal, I mean, when you remove the lather from the water, it removes the hardness of water. So when you dissolve the detergent in the water, detergent will interact with the calcium and magnesium. It provides a lather or a foam. With the help of hand or with the help of any equipment, you can remove the lather, and with that the hardness of water can be removed. Okay, this is the actual procedure of the detergent to remove the hardness of water. Okay, hope you understand about the detergent and the soaps. This is what about the detergent and soap. So last is the in-text questions. Homologous series, we already discussed in the previous slide. Homologous series with the difference, CH2 is called as homologous series. One example already given in the previous slide, CH2. Write it in the comment section or take it as a assessment. Okay. Next, draw the structure of ethanoic acid. Ethanoic acid already drawn. H2S. Sulfur atomic number 16. Sulfur atom 2 comma 8 comma 6. Outermost shell electron 6. Sulfur 1 2 3 4 5 6. So hydrogen with each bond will make one bond with the sulfur. So this is what the electron dot structure of the H2S. Propane known, you can try. F2 also you can try it in the comment section. Okay. Next, which of the given following are the undergoing addition reaction? Addition reaction means double bonded compounds. Unsaturated compounds like double bond and triple bond undergoes hydrogenation addition. They are considered as an addition reaction. C2H6, C3H8. So here if you find the difference, there are like C2H6. C2H6 means two twos are, what is the alkene? Unsaturated compound CN H2N, CN H2N minus 2. So if it is a double bonded carbon, it can undergo addition reaction. So for n number of carbons, you should have n number of 2n number of hydrogens. So if it is 2 twos are 4, it should be 2 twos are 4. So this is not a double bonded, it won't undergo reaction of addition reaction. C3H8, this is also alkane, it won't undergo addition reaction. This is C3, 3 twos are 6. This is a double bonded carbon. So this can undergo addition reaction. This is a C2H2, which is this alkyne, which can undergo addition reaction. Triple bonded carbon on addition with the hydrogen gives double bonded. Double bonded on addition of hydrogen gives single bond. This can also undergo. So this is the alkane compound which does not undergo addition reaction. Okay. Next, what is the hydrogen and what is the industrial application? Hydrogenation means addition of hydrogen. Industrial application of the hydrogen is addition of hydrogen to the double bonded unsaturated vegetable oils. It gives a saturated vegetable ghee that we discussed in the hydrogenation, addition of the carbon compounds. Okay. Next. So summary. So what we have discussed till now: introduction, covalent bond, versatile nature of the carbon, saturated, unsaturated with the branch, chain and ring. We already completed. Homologous series, nomenclature also done. And last is chemical properties. Some of the important compounds like ethanol and ethanoic acid. Last is soaps and detergent with activities and intensity questions. So this is what we discussed in the live session. Hope you understand about the carbonates compounds. If you have any doubts, you can, or queries, you can type it in the comment section. Let me know in the comment section what are the doubts. Okay, sir, understood everything. Thank you, thank you. Yes, thank you so much for your attention. Hope you have understand this fourth unit, which is a carbonates compounds. Let's meet in the comment section. Hope I will try to answer in the comment section also. Thank you so much for your attention and valuable time. Thank you. Signing off. This is Vineet and your chemistry faculty signing off. Thank you.